Right. So recording started, and I believe that last week I said we're going to start. We're going to make an attempt to do a little bit of actual coding today, right? We're going to start with some C programming. I think that we've covered. We haven't done like a super comprehensive covering um of like pseudocode, but I mean we know enough to understand pseudocode. Can I get a agreement, like raise your hand like that if you agree that we have a decent covering of pseudocode, enough to watch and create a couple of solutions. Cool. Now the thing is that um, all programming, all programming, all programs are algorithms. So the thing is, once we start programming, you still basically you're still what you would say practicing the same skill set of pseudocode. It's just that you are doing it from the perspective of um, of doing it in a structured language. Okay? And the way that CXC corrects stuff is they don't want you to write C code for your pseudocode section, nor do they want you to write pseudocode for your C section. But the thing is, once we start programming, we are able to test, we're able to actually run it on the computer, test, debug, run again, etc. And strangely enough, doing some programming actually helps you with the ability to produce pseudocode. So we're going to take a look at into the intro to C today. I have big dreams today, right? I have big dreams, and I'm not even starting with the C, but I want us to do some basic input and output in C just to understand how we will print to the screen, how we'll take data from the user. I want us to take a look at the if structure, well, some sequence, some if, and maybe a basic look at the three loops in programming. Okay, maybe we'll get through all, maybe not, but we had a try. Before we do that, I want to address some of the work that we have outstanding that some of you all might have attempted and uploaded, and others didn't, or others might have just looked at it. But I don't want us to go forward and we abandon like the pseudocode exercise. So things that I would have put up on Classroom, we're just going to, because I never addressed it, and just if I cut off is because lights go away, because lights just dipped by me here just now. So if it is that lights go well, we'll have to just kind of, hopefully it'll come back soon. If not, then we will arrange another day to meet and go forward. Okay, but we moving forward, right? TNTech is not my friend where I am living. Oh yes. All right. All right. So let's take a look at the questions that we would have had to deal with. So I'm going to just share the Blackboard. And once I share the Blackboard or the whiteboard, I want us to take a look at a couple of the exercises. These were some of the sequence exercises that we had a little while back. Right, so this is one of the sequence exercises, and we could do it pretty quickly. Everybody's seeing it, right?
Yes, sir.
Right. So just talk me through. Any volunteers? You could put up your hand, or you could just start talking. If it is that. Any volunteers? Because we could probably do these in C as well. And these two sequence exercises here, I want us to do the pseudocode, and we'll take that as our first attempt at C after we just kind of look at the structure, etc. See. So anybody want to walk me through?
See, I could give you the first half, say, and somebody had to hop in and give you the second half.
All right. Let's see how
Right.
far we can carry this. Let's go.
So first, right, um, right. So we declare our variables first.
Mm-hmm.
So we have to put in gas.
Okay, so gas. And what data type is gas?
I think
Actually,
it's
I could type this. I don't have the subject line into my handwriting for this. All right. So gas is what?
real, say, real.
Okay, so real. Uh-huh. Gas. What else?
I think you also need the cost of the gas. So, well,
Yeah.
gas is cost.
Okay, so gas underscore price. And what else do we have? The average. We know
Miles
the
per hour.
right. We have miles per gallon. So we have these things. We could declare the distance as an integer, right? And the distance is 180 miles multiplied by 2, correct? So that would be, let's just put 360, correct? Everybody agree on the distance because we have to make the trip there and we have to make the trip back. So what is the first thing that we do? The first thing that we do is that we enter these variable, these values that could be anything. So we print out to the user what? Please enter price of gas and MPG. Yes? And we will input G underscore price and MPG. So everybody with me so far? Yes?
Yes, sir.
Yes,
Okay,
sir.
okay, good. What next? Where do we go from here? Yeah, real.
So so can we declare a variable like the amount of gallons? Something like that.
The amount of gallons. Give me more information.
So what I said was, well, when you enter the price and the
Mm-hmm.
I think that meter per gallon,
Miles per
the,
gallon.
yeah, the
Uh-huh.
amount of gallons would be equal to the miles divided by the amount per gallon.
Okay. All right. So the amount of gallons, so we need that's the variable gas that we have here. So the
Or that gas
gas
there. Oh,
is equal to the what?
the
To the
miles,
MPG. Uh-huh.
the distance, well,
Or the distance divided by the MPG.
the distance, yeah.
Okay. So good. So the gas should be the distance divided by the MPG, right? So of course the miles and the distance will cancel out, and that will leave you with how much gallons that you need. Okay. So this is the amount of gas that we need. Now what is the next step? The next step would be to
Figure out the price.
Right. So we need a variable for the total cost. And we could say now total underscore gas underscore cost is equal to the gas multiplied by the gas underscore price. Yes?
Yes, sir.
And so it leaves us to just simply print out what? Print out the cost of the trip will be underscore gas underscore cost. Okay? So you end up with the total gas cost. So let's plug in some data and see if this works. All right, so let's say we run in this algorithm. We enter the price of gas. The price of gas is $6. Right? That's the price of gas per gallon. And the average miles per gallon of a car. Let's say the average miles per gallon of a car is 15 miles per gallon. Okay? How much gas will we need? We will have to divide 180 by 15. 15 could go into 18 one time. This is 1 by, right? So 150. This will end up with 30.
So you're not supposed to be dividing by 360.
All right. Thank you very much.
Yes,
360. I watched the top here and not the bottom here. So it's 15 into 360. Okay. So 15 into 36 is 2. 2 by 15 is 300. We have 60. 15 into 60 is 4. 4 by 15 is 60. We end up with 24, 24 essentially gallons there. So we want to multiply 24 by 6. Right? 24 by 6 is what? 72 by 2. 72 by 2. Right? Sorry, by 2. Right? That is what? 2 by 2 is 4. 2 by 7 is 144. So the total gas cost should be $144. Am I correct there? Is my maths all right?
Yes, sir.
Yes, sir.
Okay, good. So it seems to have worked. We're going through, just going through the questions because I don't want to leave anything undone. All right, so we have another question that we had to deal with, and I'm using these as the basis for the first programs that we write. Okay? These first little sequence programs that we write when we start up C. So this is why I want to make sure and go through these questions here right now. So did my program crash? It's not moving. Okay. Why are you giving trouble like this? Good. Joe would like to build several bookcases that are different heights and widths. All would be 12 inches in depth. Right? So all the bookcases, if we go this way, is 12 inches. The bookcases will have 3 shelves in addition to the bottom and the top. Write a solution to print the number of feet of 12-inch wide boards that Joe would need to complete a bookcase, given the height and the width. So we know that all of the bookcases will be 12 deep. Okay, that come like a depth could be like a constant. But we'll have variable values for width. Right? So this is depth. This is width. And let's just say, for instance, our example width that we have is 24 inches. And let's say we have height. And let's say we have a height of 36 inches or something so. Right? what we eventually have to work out, and this is what we have to do in our mind, is that this is a panel here. We draw in a bookcase. So this is one of the panels here. We'll have to have another panel like that, right? This is the top panel here. So the top panel is 24 inches by 12 inches. And we have we have 3 shelves like that in the middle. And then we will have another panel on the side here that is the same width as this. So we have 2 side panels and essentially 5 shelf panels. Correct? Everybody with me? Everybody seeing my bookcase?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
A little find it looking good?
Yes.
Looking a little wonky, but that's the design. It will hold up. Right? It'll hold up. It's for irregularly sized books, you know, like books that get water damage. So the book all over the place. Right? It's specifically designed for that. It's actually more expensive than the regular bookcases.
You're getting robbed.
Okay? Yeah. Very elite stuff. I don't know if I could you know could buy one of these bookcases just yet. All right, so we end up with we end up having to understand something, right? We understand now how many shelves that we have and the bottom and the top. So essentially, we could call that 5 shelves, and we could have 2 side panels. The front and the back end, they all the way through. So there's no board in the back or anything. So from our understanding here, just watching this diagram, we know that to get the bookcases, the amount of boards of 12-inch wide boards that Joe would need to complete a bookcase given the width and height. Okay, so we have 12-inch wide boards and 12 inches in depth. Okay, right. 12 inches in, all would be 12 inches in depth. The bookcase would have. Something feels a little incomplete about this. Maybe we essentially have 12 by 12 boards that we have to put together to work with this, right? So we have essentially 1 square feet. They're asking us what is the total square footage, right? Because if the board is 12 inches by 12 inches, that's 1 square foot. Essentially, this question is asking us what is the total square footage that is required to build a shelf once we are given the height and the width. Everybody agrees on that? Everybody understands where I'm coming from? Yes?
Yes, sir.
Okay. And you notice that there's something that we do when we do these kind of questions. And this is where the sequence questions become important. And this is what needs to be translated to every programming question that we do. All right? To every programming question that we do. What is it? What is it exactly that I need to do? I need, and this going back to the problem solving process, we need to understand the problem before we could try to solve the problem. So this is why sometimes it might seem like I'm doing extra, or it feel like you're doing the most with regards to understanding. You're drawing a diagram or something like this and given values, and then we try to understand, well, this one here is a variable value. Okay, so this one here is a variable value because that's the width, and this one here is a variable value, but this one here is a constant value. But it's better you try and gain a full understanding of the problem so that this aids in coming up with the solution. So now from this visual, I could see that I would need 5 multiplied by height by depth boards, and I'll need 2 multiplied by, sorry, not height by depth, that's width by depth. Everybody here just hammer writing things as, you know. That's width by depth, and 2 multiplied by height by depth boards, according to what we drew here. Agreed?
Agreed, sir.
Yes, sir.
Right. So now this algorithm becomes super easy to work out, because all we have to do past this point is what now?
See the variables.
Right. We just have to declare our variables and ask for the width and the height. Okay, let me just address Gabriella's question. Why am I including which 12 inches? If you could clarify that question. Okay, so take it that we want to build this, but we want to know how much boards we need. And we know that each board that we get is a little interlocking 12-inch by 12-inch panel. And all of these could interlock with each other, right, to form the shelf that you need. So if it is that we have these boards that could interlock with each other, essentially I'm going to take one of these boards and put them here, a second one and put them here. I'll take one and put it here, one and put it here. One and put it here. This is addressing Gabriella's question. So you kind of put the boards together so you'll know exactly how many boards you'll need. Sorry, that last drawing was terrible. And another one here. And again, the same for the 3-inch, the 3-foot area. 1 board, 2 boards, 3 boards. 1 board, 2 boards, 3 boards. And you could essentially now, because they say you have 12-inch wide boards, and you know they already established that all boards are 12 inches in depth as well. So if it's 12-inch by 12-inch, essentially this question is asking you, how many 1 square foot boards do you need to build a structure of a given width and height? You follow me, Gabriella, in terms of the justification for the boards at this point? Because the ones on the sides are width by depth, and the ones on the shells are height. Sorry, the ones on the sides are height by depth, and the ones on the shells are width by depth.
So the question basically asking how much boards of these dimensions Joe would need to build a shelf.
Yes, how much 12 by 12 boards would he need to build a shelf? Yes. That's what the question comes down to. It doesn't say it in that manner. It tells you in the beginning, the board is 12-inch in depth, and then the board is 12-inch in width. But the shelves go by width, and you'll have to turn them same boards and use it for height. Okay, and that's why we end up with 1, 2, 3, 4, 5, 6 plus 10, 16 boards in this case. All right, but what we do know is and we could express it as an algorithm. We express it as the depth, or D for depth, is equal to 12. Right? We know that we have int W and height, the width and the height. Now, all the boards that the board itself that we interlocking together is 12 by 12. But the width, the final width of the shelf is what this W represents. This is the width of the shelf. Okay? And this is the height of the shelf. So this is the finished width and the finished height of the shelf. And we want to know how many boards we would need to get to that width and that height. Okay? All boards are by 12. So even if it is that I wanted a board that is a bookshelf that is, let's say for instance, we wanted to build a bookshelf that was 40 inches wide and 50 inches high. What it means is that we will use 1, 2, 3.5, or 1, 2, 3 1/3, essentially 12-inch boards to get that. Because at the end of the day, this goes back 12 inches. This doesn't change from 12 inches. So we will have 12 inch here, 12 inch here, 12 inch here. Sorry, 12 inch here, 12 inch here, 12 inches here, and the last one will be about 4 inches. You'll have a small board inside there, right? Because it's 36 and 4 will give you the 40 inches width. You all understand where I'm coming from?
Yes, I follow.
Okay. Anybody doesn't follow?
I think I follow, sir.
Okay, good. So once we have the width and the height, let's ask the user now to enter print, enter the width and height that you would like your cupboard to be. So we ask for the width and height of the cupboard. And once we could get the width and height of the cupboard by inputting W and H, what we do know is that for one shelf, once you always know how many shelves. They told you that the amount of shelves is static, right? That's like a what do you call it? It's constant. You always have 5 shelves. It doesn't matter if the height is 100 feet. You're only getting 3 shelves on this bookcase. Okay, you have some long books. If the height is 3 feet, that's fine. Everybody's fine with that?
Yes, sir.
Yes, sir.
Right. So we could do 2 things. We could either enter the width and height in feet, or we could enter the width and height in inches. That's something that is up to you as the programmer. If you enter the width and height in inches, you're going to have to do the division by 12. If you enter it in feet, all now you have to do is basically, multiply that amount. Let's enter it in inches because they've given us in inches. Okay? So in terms of the square footage, when we have the square footage, if it is that we have to get the square footage in general, right? The square footage in general, we will end up having to divide by 12 here. And here as well. Okay, so that height multiplied by depth, or the width multiplied by 12 depth, if it is that you're putting that width and the height in inches. So enter the width and height, and let us be clear as programmers. So let's say in inches that you would like the cupboard to be. And remember, we're testing these things tonight, eh? Okay, so we're actually going to be able to put in a value into our program and get some sort of output from it. Okay. So what do we want to do? We want to do what we just established up here, right? Total amount of shelf boards and total amount of shelf boards and total amount of help me out here, sideboards. So we could say number shelves, number shelf boards, and number of sideboards. And we're working these out. So we see a number of the shelf boards is equal. So 5 multiplied by the width multiplied by the depth divided by 12. And the same thing will be for the number of sideboards. So to get the number of sideboards is going to be 2, because we only have 2 sideboards, multiplied by the width, multiplied by the depth, divided by 12. And we will test it here, and we will test it in okay, and then we could say total number of panels needed. So we could shortcut that. We could say the total number of panels needed is, and you could say the number of shelf boards plus the number of sideboards, and do the addition inside of the print statement. Because programming allows you to do that.
So, and the second line supposed to be height by depth?
Height by depth. Second line?
No, and no side number of sideboards.
Yes. Thank you.
Yeah.
All right. So this is height by depth. Thank you very much. So let's check it out. And this is why we test our solutions to see if we write stupidness like Mr. Valder is just right there. Okay. So we have enter the width and the height. We know that the depth is always 12. Enter the width and height in inches that you'd like the cover to be. So if it is that I wanted this shelf to be 72 inches wide by 36 inches high. Okay, it's essentially a 6x3 shelf on its side. We'll end up saying, okay, 72 by 12. So 72 by 12, which is equal to what? Anybody with the quick maths? Nobody? 864. Okay, 864.
That's
Yeah?
easily 100. Yeah. Yeah. That was
Divided by 12. Right, 864 divided by 12 is, hey, we're back at 72, essentially. Multiplied by 5. Okay, I'm going to have to divide this entire thing by 12 again as well. I'm going to have to divide this entire answer again by 5. 72 by 5. Because 360. Right? 360. So 360. Sorry, divided by 12 again. Right. Hold on, eh?
So that'll be 30. 30 shelf boards.
Yes. Right? So because sorry, we divide by 144 here, 12 by 12. So you could put it there, right? 12 by 12, because we're dealing with the inches, not the, I got tied up with the 1 foot in my head. So it's 12 by 12, So when we get this 864, sorry, you're dividing by, of course, the square footage of the one block in inches, which is 144. Okay. So I think maybe that's where the question had come from, because 12 by 12, what would be the 1 square foot would be 144 square inches. And we're dealing with inches right now. So 144. So we end up with 864 divided by 144, right, which would be 6. And then we multiply the 6 by the 5 panels, because for each shelf, that 72 inches is 6 feet. Okay, the 72 inches is 6 feet, and we need 5 6-feet panels, or 5 panels of 6 feet put together. So we end up with 6 by 5, which is 30. And the same thing for the height. We end up with 36 multiplied by the depth, right? So that's 36 by 12, which will give us what in inches? 36 by 12 in inches is 432, right? But we wanted to convert it to square feet and not just, have it in inches. So we have the 144, right? So 432 divided by 144 will be 3. And 3 multiplied by 2 is 6 panels. So at the end of the day, we will need 36 panels to get a 6 by 3 shelf, where each panel that we put together is 1 foot. Everybody's with me? Sorry, I had a little brain lapse on the maths.
Yes, sir, Richard.
Right? But it happens.
Yes.
Forgive me. I had a long day. I was up in the people in school and all kind of thing. All right. All right. So we want to take these. We want to take these and we want to go. And do an assignment with it. Okay, we want to do an assignment with it. We want to be able to. Now you all seeing the screen properly, right? You all seeing the
Yes, sir.
whiteboard? Okay.
Yeah. Yes, sir.
Okay. All right. So we now want to go and we want to try and see if we could implement these in the C programming language. All right. So we're going to open up our compilers. I'm going to stop presenting. I'll share my screen for now. Okay. And we wanna open our compilers. I have code blocks. That's the compiler that I would have put on Google Classroom. Anybody did not get their compiler installed or anything, so?
Yeah, so I didn't get it because of the Chromebook.
Okay. Well, yes, that's something that we had to. I feel we had to tackle it from the Linux memory key. You're gonna have to learn a little operating systems to get your compiling in. But we will work around it. Either that or borrow somebody Windows machine, if
Okay.
possible.
I don't have any, but
Okay.
yeah.
All right. Well, then you'll have to do a little research into booting up from. But even to make the flash drive, you will need a Windows machine to be able to make that bootable flash drive. But you'll message me and we'll come up with a solution.
So what device
Okay.
is she on?
Okay. Right. Sorry about it. Good. So we are in.
Hello, sir. Wait.
Well, guess we're taking a break.
Yeah, well,
to just keep all of your files in. And this is going to be my first
So you stick for a good
program,
5 seconds there.
just for you or for everybody.
Everybody.
everyone say.
Everybody say.
Serious? All right. What I was saying is that I created a folder on my C drive called Valdez underscore SC underscore C, right? You could just name it your name underscore C. The SC for me is supplementary classes. And I'm going to store all of my files inside of here. When I name my files, I don't put any spaces in the name. So I can name my file hello world.c. Now notice that the first letter of the second word is capitalized. That's a naming convention. That makes it easy to read. And all of my files, I put the .c. Okay? I'm saying save this as a C file. And some of you all, depending on your install settings and stuff like that, it might save as a .cpp by default. We don't want the .cpp. We want the .c because we're programming in C. Okay? So this file is going to save on your folder. If it is that we go here, we should go to the file location and we should see it here. It's an empty file. There's nothing inside of it. This is it here in code blocks. Any of y'all doing it along with me at the same time, or?
So well, it's a little different with I think Linux or something like that. The machine I run it on.
Oh, you have a
Little
Linux machine
different.
as well?
But I think it's like the same. Jada has a
Okay, so
Linux machine.
well, a Chromebook, but we'll work it on the Linux machine. I'll speak with her and see how we could work out where we at. Right? But for now, I guess we just run through the windows. Now, as it goes, for the majority of the programs that you write, from now till the end of your tenure in sixth form, because they're C programs, and you might write a couple in a couple other, yeah.
Somebody asked if they could use an online compiler.
Yes, an online compiler is fine. Yeah, so you can, once it's an online C compiler, it's fine. Okay. So we all of our programs start with include, and we use these two libraries, stdio.h, which is the standard input-output library. This library holds important input, output functions that we will use. And then we have include stdlib.h, and this library holds important general functions that we use. Okay? This is a comment. This is a comment. It is for us and other programmers to read things we leave about our code. Now, we also have a multi-line comment, which is this. This is a multi-line comment. Everything in between these are for us to read as well. It covers multiple lines. Okay, So we have multi-line comments, we have single line comments, and these are how we, we communicate with other programmers, or you communicate with yourself in the future about what you want to do in your program. Okay? Any questions about the comments so far?
No, sir.
Not really, sir.
All right, good. Yeah, comments aren't really super exciting or anything. So, right? So the first thing that we have to do is that we have a function called main. And all C programs have a main function. And this is something that you will notice across more than just C, across many programming languages, right? Java main function, this is the function from which all programming starts. So we go int main, and some things I would tell you not to worry about too much, return 0. This is just the structure of our program. And this bracket here indicates, this bracket indicates the start of our program, and this one indicates the end. This return statement matches with the int before main. It's not important right now. Okay? That return statement will become important to us in the future, but don't worry your head about it too much right now. So you notice that I do something. Every time I start, I open something, I close it immediately. That's a good habit to have in programming. Once you open a bracket, you close the bracket, so that you have now a fair idea of the control of things, because you could now label your bracket start main, end main, and you will know what's inside of main and what's outside of main. All right? Everybody's good with this? This is just a program to print hello. This is just a program to print hello. So we want to now go and see how we print things to the screen in our program. To print things out, to print out things, we use the printf statement. So we have printf, and we could say, hello world, I am new to C programming. And whatever you put in between those quotes that are inside of this bracket is going to print out on our console screen when we press build and run. Build compiles the program, which means that it looks at all the statements, make sure it has no error, and just creates the executable file, and then will run that executable file. So there's build, if you just want to check your code for correctness. There's run, so if you want to just run the last completed compile code. We never compiled this before, so if I click run, I'm going to get an error, right? So it's telling me, I don't know if you all seen the prompt that came up. Yes or no?
Yeah, we've
Yes,
seen
sir.
it.
Right. So you see it has not been built yet. Do you want to build it yet now? Well, no, not yet. Okay, and nothing comes up. All right, and I get all kind of problems. Yeah. Okay, let me share properly again. Okay. So now I want to compile and just make sure I have no errors. Down here, it tells me that it finished with 0 errors, 0 warnings, and it took 0 minutes and 0 seconds to build the file that needs to run. And so if I run it now, it shows me what I have inside of here. Hello world, I am new to C programming. Yay. Have you tried it on your end?
Yes, they're looking good.
Looking good. We're off to a good start. Right? So if it is that you type this up and your everything worked without any problems, you're gonna be a good programmer. If it is you type this up and you encounter problems, then you're going to be a great programmer. Right? So, because we could expect to meet some problems on the way. And remember, part of programming is debugging, seeing what is the problem. I will warn you all online here, and I'll warn my class tomorrow when I speak to them. You will lose sleep over a semicolon, okay? Or you will lose sleep over an outer place bracket. Something like that could make your program look like it's correct, but then it's not. And it's not giving you any kind of compile errors, but you're getting all kind of strange behavior. Or you might get a compile error from a missing semicolon, but because of where the semicolon is missing from, it might not report the exact place. So you might have to go looking for it and digging for it. Okay, but those are days to come. For now, we've written our first program and we've output some information. So I could change this and I could say, hello, Mr. Valdez. I am new to C programming. And if I put that inside there, hey, it's there. Okay. But we will come back because I don't want to start off with manipulating strings or string variables. I want us to, however, learn about input. Okay, so the next thing that I would do is I want to create another empty file. I want to save this as program2.c. Because I am a good programmer, I copy and paste everything from here and delete what I don't want, which is this, and this is fine so far. All right? I could go back to this and say, hey, my first output statement. Okay, my first output statement. And now I want to use some variables and input. So I have my program and I want to utilize some variables to do some things. Let's start out basic. Let's start out very basic. We're going to take two variables. So I could put in my comments. This program takes two variables from the user and adds them. So this program takes two variables from the user and adds them. And how do I do that? Well, first I will need two variables. So I could have two integer variables, int a, comma, and b. So I declare an integer or two integer variables. Declare two integer variables. Then what do I do? Then I want to get these variables from the user. So I could say printf, part of my input has to include output because I have to instruct the user. So I have to say, please enter a number, and I'm going to do this as two separate statements for now. Please enter a number, and notice that I put a space here because I want a space to print out between the colon and the number that I enter. I would say scanf, %d, ampersand a. Wow, that's a lot to be able to take in a variable. What does this mean? What did I do here? Well, this line, I asked the user for a variable. And then down here, I store the variable as an integer in the variable A. So that's what this does. Scanf is a function, and it means read some input from the user's input stream, which is the keyboard. %d is a placeholder which tells me that I'm expecting an integer to be read. So %d means integer. We have other placeholders for other variables. Don't worry too much about it. We'll ease into using that. And then ampersand A, right? It tells me where in memory to store the number that you put in associated with the variable A. So that's what this means here. And if I do it for A, then I could do it for B. Sorry, B. And I want to put something after A. Sometimes our input, when we press enter on the keyboard, there's a little extra garbage that goes in along with the variable. This getchar cleans the input from the keyboard. So I follow my scanf statements with a getchar. This didn't used to happen all the time. I can't remember doing this when I was learning programming some however long ago, back in the early 2000s when I was learning C. But for some reason, code blocks and modern C requires this getchar after the scanf to clean it up. It is what it is. Don't worry about it. I wouldn't, just think to yourself, well, once I enter something using scanf, use getchar. Anybody have any questions? Any hands up or anything so? Nope. All right, so everybody's happy. Everybody ran off screaming. Which one?
Still here, sir.
Okay, still here? Wow. I don't know if that's wise or not. Now we want to do the processing. So we want to say, all right, let's say for instance, we can have a sum, a variable called sum, and we could say sum is equal to A plus B. Add A and B and store it in sum. And then lastly, you want to print out printf, and you'll notice that we do the same thing like we did with the scanf. We have to use a placeholder. So the sum of %d and %d is %d. And afterwards, I put A, B, and sum. And it falls into the placeholders in the order that it is listed. So this %d will take the value of A, this %d will take the value of B, and this %d will take the value of sum. Everybody's with me here? So I know what you all want to do. You all want to run it and see what happens. So when we run it, the program asks me to enter a number. I enter 555. Enter a number 111. Sum of 555 and 111 is 666. That seems correct. So we have a working program. So, and you know what the objective here is, that we want to go back to our algorithms that we wrote at the beginning of this class and write those algorithms as what you call it, as programs. Any questions? Yes, you will have access to the recording on the Google Classroom itself. So I'll post it up as all the other weeks have been posted up. All right, so in classwork, you'll see the weeks, week 1, week 2, week 3, week 4. Week 4 class video, week 3 class video, week 2, week 1. So it's all there. So this is week 5. We will be able to access this recording on the Google Classroom. Oh, this is your first class. So you go to classroom.google.com and you enter this code right here. You enter this code, classroom.google.com, enter this code, and you will be added to the Google Classroom. I could just actually copy the link and paste it in the chat. Just click on this link. All right. So we're back. And we want to tackle our first algorithm. Okay, so this is something meaningful now. This is not just a simple add two numbers. This is you know, we've written the pseudocode for it. We want to apply it to our program. We want to write a program in it. From what we've seen so far, do you think you can write up? Do you think you could write up the program for this in C, given that we've seen this example here in C? Yes or no? I would like to ask you all to take 15 minutes. Let's take 15 minutes. I'm going to ask you to write it up. And then when I come back in 15 minutes, we'll take a look at the solutions that you all have. Okay? So I'm going to, if you get your code writing and working, I'm going to put a little portal in the Google Classroom. You could upload it and we'll use your program and test it out. Everybody's fine with that?
Yes, sir.
Yes, sir.
Okay. So what I'm going to do is I'm going to leave the screen up. I'm going to pause the recording right now. Leave the screen up. And we will take some time and then we will resume the recording when we're going through the solution.
Sir.
Okay, so we've resumed recording. I'm going to share my whole screen, my entire screen to share. And we're going to take a look at, so we're going to create a new file. So I'm going to name this student work.c. And I'm going to, Emmanuel submitted his own first, so I will take a look at Emmanuel's exercise. So I'm going to copy his code and we're going to paste it. And let's see if what Emmanuel has works. So I've compiled, I have no errors for compilation. And let's see how Emmanuel's code works. So we run it. Please enter the price of gas. Let's see, gas is $7.50. Ah, sorry, I put 750. All right, I'm going to start that over.
Why are you trying to do something?
Sorry. So far, you're right. So we have float. And oh yes, so I see that Emmanuel went and he looked up the price of the placeholder for float, which is %F at this point. So very good, Emmanuel. All right, so we have the data type float in C, and then we had %sign F as the placeholder for float. So I have yes, Johnny.
No, I believe my hand was up by mistake.
Oh, okay. All right. Yeah. So we have float gas price miles per gallon. So we can use some floating point numbers inside of here. So let's say we have 750, all right, as the price of gas. Enter the price of miles per gallon. Price or amount of miles per gallon? It would
Well,
be amount of miles per gallon for gas that you could get. Yes?
yes,
All
sir.
right, so let's say we get 22 miles per gallon. The cost of the trip will be $122.72 at 750. So let's see. First, you worked out the gas, right? The amount of gas that we would need, and I'm just gonna modify your code so that we could see that amount of gas we would need. So I'll say printf. Okay. We will need %sign F liters of gas. And that %sign S is going to be that gas there. Okay? I'm going to put a get char here. And a get char could use to pause output and to allow you to skip lines as well. I'll show you an alternative way to skip lines when we take a look at the next person's code. So enter the price of gas. Let's go back with 750. 22 miles per gallon. Oh, it did not go down to the next line. And that is because, like I said before, we did not put get chars after our scanf. So this get char acted as the first get char after a scanf. So let's see the behavior of it now. 7.5, 22. We will need 16.363636 liters of gas. Okay, and 16.363636, right, by 7.5 will give us 122.727272. Let's just do 16 by 7 and see how close we are, right? 16.3636 multiplied by 7.5 is 122.727. So we are correct. So very good work, Emmanuel. Next up, we have Johnny. So I'm just going to copy and paste over your code for Emmanuel's code, and we take a look at it. Okay, so you had stdio.h coming in here, but where is stdlib.h? Right, even though code blocks might pull it in automatically, I still encourage us to take it. So I see that you have your get jars after scanf. That's good. And let's see if we got the total price. So we're going to use the same values. 7.5. We're missing something here. Oh, sorry. We're working with integers here. So let's do 7 because we're not using floating point values. 22 miles per gallon. The total cost of gas is so the total gas.
Again.
We forget the %sign D here and to put total underscore gas underscore cost here. All right, but in terms of the amount of gas that we'll use, where was the calculation for that? So we have the price of the gas, and we didn't, where is this gas price being calculated? You see where we have an issue here, Johnny?
Yes, sir.
Right, so we forgot the line where the actual price of the gas was being calculated. And I think that gas was the amount of gas. So this should really be G underscore price. And what we end up with here is the gas, that's the total amount of gas, and that was equal to the, what was the total distance? 360 divided by mpg. So the miles per gallon. Because they told us that the whole trip was 360 there. So let's see if we can get as close as possible. We had 22 miles per gallon. Yeah, we came close enough. The total cost of gas is 112. So we managed to fix this up, but you know, as we see, integer mightn't be the best data type to represent this, because we're dealing with gas prices, which could be, you know, you could have half a gallon of gas, and we're dealing with cost. So you could also have half of you know, $1 or something. So lastly, let's just take a look at sets. What's set uploaded? All right. So set. Good. So set also used the floating point. So I'm glad that you looked that up. Let's compile and see. No errors so far. It looks similar to what we have. Enter the gas price. We enter the gas price. We enter the miles per gallon. We calculate the distance over the miles per gallon, and we multiply the cost by the price. And he also formatted his final value to 0.2. So that's good, so that we only get it we get 2 significant digits. So again, we enter gas price is 7.5, because I know that this supports floating point values, miles per gallon 22, and we end up with 122.73. So we got it to 2 decimal places, right? Which is good. So good job, Seth. Good job, Johnny. Good job, Emmanuel. Did anybody not understand what we did? Anybody did not understand what we did, or any of these gentlemen did? Or does anybody have any questions? Okay, so no questions, right? I know you all must be seeing a whole lot of stuff on the screen, just infinite me's and stuff like that. So last thing I wanted to show you all, I just wanted to run a quick little example of some decision logic and looping in C. This is just to give you all a taste of what is to come, just to acclimatize you guys. So let's save this. Let's name it example if and loop. And I'm only going to use the for loop for now. Okay, so now I'm just going to copy this. As you know, let's be a little lazy. So you just copy and paste. We have the return statement, and yes, your program will work without this return statement, but it's just a little more complete with it. When we get to learning functions and you see what the purpose of a return statement is for, this will just make a little more sense to you. So it's not going to break your program if you leave out this, but you know, it's just good practice, because you don't want to, you know, leave out the return statement from your main. So when you start in a program blank, it should be something like this. Okay, let's go back to that exercise. What I wanted to go back to was that exercise that that we did with the triangles. And so I'm gonna type it up and annotate it quick, right? So I'm gonna do the triangle result here. Triangle result based on values entered. And we just to go back to justify, the solution for the triangle. If we have 3 values and we want to ask whether or not this was something that was given earlier in the year, we have 3 values entered, 3 integer values, and we want to figure out whether or not these 3 integer values could form a triangle. We will see here by example. Let's say, for instance, we have the value 9, 6, and 7 entered. We could have a triangle of size 9, a triangle size 6, and a triangle size 7. Okay? But if it is that we have 3 values entered, 11, 2, and 7, these values will not be able to form a triangle, because if I have the side that is 11 long, then I have the side that is 2 long, the side that is 2 long will lie down here, and the side that is 7 long will lie down here. And we will have like a little we 2 inches short for joining up a triangle. So what is the rule for making a triangle? A rule for making a triangle is that the sum of 2 sides must exceed the third side. Right?
So it can't be equal to the third side?
It can't be equal to the third side because it would then be a parallel line. Right? It'll just be 2 lines lying down on top of each other. So again, even if this were 11 and 4 and 7, okay? Again, what you'll end up with is the side for 11. You get the side for 4 and the side for 7. And what you'll end up with is just 2 parallel lines just lying flat on top of each other. So it must exceed, even if this is 4.1, you're going to be able to get that little arc there, and that's going to form a triangle. But if it is 2 parallel lines, they'll just lie down on top of each other. So knowing that, we could form a statement getting 3 sides. So let's say we have 3 sides: int, S1, S2, and S3. Side 1, side 2, and side 3. So these are the variables for the 3 triangle sides. Variables for the 3 triangle sides. And we want to ask the user to enter them. So I could say printf, and I'm going to be lazy here. I'm going to say, please enter the sides of the triangles separated by commas. And what does that mean? That means I could go scanf, %sign B, comma, %sign B, comma, %sign B. What does that tell me? It tells me that I expect the user to put in %sign B, comma, an integer, comma, another integer, comma, another integer. Okay? I could also use floats for this, but I'm keeping it simple. So I'm using integers, and I'm saving it into ampersand S1, ampersand S2, and ampersand S3. Okay? So this will store my 3 values. 3 values to my variables. And then what do? I put a get char to clean my input, because that's just what I do after scanf. So now how do I represent this? I could represent this in a simple statement. I could say if right, S1 is greater than S2 plus S3. And then I want to say OR. So in programming, we have and we have OR, but and is represented via double ampersands, and OR is represented via double pipes. These pipes are the key above enter. Okay, so we have and being double ampersand and OR being double pipe. And the pipe is the key above enter. When you hold shift and the key above enter with the backslash, you get the pipe. All right. So if S1 is greater than S2 plus S3, or S2 is greater than S1 plus S3, or S3 is greater than S1 plus S2, what do we do? If any one side is greater than the sum of the other two sides, we could print F. This is not a triangle. Else it would mean that the opposite is true, right? We could print F, and again, nice lazy programmer vibes. Copy and paste. This is the triangle. And so what do we do here? We can run it and see how it works. So let's use the same values from the example we had here. 11, 4, and 7. All right, 11, 4, and 7. Oh, sorry, I made a mistake. This has to be if any one side is greater than the sum of the two sides. If in any of the cases there. Right, so that's where so all of these have to be false. Okay, S1 can't be bigger than the other two, S2 can't be bigger than the other two, and S3 can't be bigger than the other two. All right, it can't be equal to either. So in this case, it has to be greater than or equal to. All right, it can't be is greater than or equal to. So if it is greater than, then it's not a triangle. If it's equal to, it's not a triangle. It has to be that the value is smaller than the sum of the other two. So let's see, 11, 4, 7. This is not a triangle. According to what we just tried just now, we got the correct answer. Right? Let's run it again with some values. 11, 2, not a triangle. Let's run it with some known triangle value, right? 3, 2, and 2. This is a triangle. So we know one side is greater than the sum of the other two sides. No one side is equal to the sum of the other two sides. So this is just a quick intro, right? So this is saying here, if any one side is larger than or equal to the other, then it is not a triangle. Otherwise, it is a triangle. Okay. So, if statement example, and let's just take a quick look at a for loop, and then we can call that a session for today. Okay. Anybody have questions so far? Any hands up? Everybody
So
going
you could go
quiet,
back
boy.
to that because I want to take a screenshot of it, if you could.
Okay, I will upload all of these codes. I'll try and upload the
Oh,
code
okay.
tonight. All right, but the video might come a little later. I heard a question, or Johnny, you have a question?
No, sir.
Yeah, your hand up.
Yeah, his hand has been up for the longest while, I think.
Serious?
Yes, sir.
All right. Okay. Well, all right. So let me just do the for loop. I'm just doing the for loop just so that we can see it in action. And then from next week, we're going to start doing all kind of crazy things with if statements and loops. All right. So again, I want to start with, oops. Hey, what did I do here? Copy, paste.
Excuse sir, I have a question.
Mm-hmm.
Yes, sir, if you could just go back to the last one, please.
Yeah, no problem. Yeah. Oh, I named it if and loop. And that should just be if. Yes.
Yes, sir. So on the if line, it have any what is called semicolons after the if statement?
No.
No.
No. You don't put a semicolon after the if statement.
Okay, sir.
The if statement is the control structures for it are defined by brackets. And brackets are optional if this is only one line. So in the case of this, I cannot put brackets and this will work. But anything more than one line, right? Anything more than one line, it
Yes,
will require brackets to work. So I kind of just leave in the brackets because I don't want to. That's something that could confuse you until you get used to it. So
yes, sir.
I really don't want to make anything difficult.
All right, sir.
Okay. All right. So for a loop, again, I just want to the objective here is to enter a value and print asterisk for that value amount of times. So enter a value and print asterisk for that value amount. What do we do? The first thing is that we need a value that we can enter, right? AMT. So int amount. We want to ask the user for a value. So we could say printf, please enter a number to print the amount of stars for. So we'll put a semicolon here. We do like what we do, scanf, %d, ampersand amount. And this amount is how much times we want to loop. Okay? For our for loop, we will require a counter. Okay, our for loop in C is just like what we did in pseudocode. We have a counter, we have a start value, we have a stop value, we have an increment. So we have C, and we will say for C is equal to 0, semicolon, C is less than amount, semicolon, C is equal to C plus 1. What did I do here? I essentially said for counter is equal to 0, right? Counter continues until it meets amount. Counter goes up by 1 each turn. So counter goes up by 1 each turn. Wow, turn, T-E-R-N. Stavales, you need sleep. All right. So that's what this is saying here. That's what this is saying here. Counter starts at 0. All right. Counter starts at 0. Counter continues until it meets the amount, and counter goes up by 1 each turn. What do we want to do? We want to print an asterisk. Okay? So just print an asterisk. And that one asterisk will print out counter amount of times. So let's see it in action here. If we have 5, we have 5 asterisks here. If we have 500, we get 500 asterisks printed out. Okay? What if I want the asterisks on a new line? I will have to use the new line character \n. This here, \n, is a single character which means start on a new line on the next print statement. So if I want them going down instead of across, I could put a \n, and now 5, I have 5 asterisks going down. Okay? I have 500. I have 500 asterisks going down. So it's just, you see, it's 500 asterisks. All right. So any questions before I leave?
Not from me,
Yes,
sir.
no. No,
No,
thank,
sir.
all right, good. All right. Okay, so we're leaving in a good space. Everybody is, we're in agreement. Yeah?
Yes, sir.
All right. So what we'll do is this just requires some practice. And what I would suggest that you do is that you on your own, you try to reproduce what we do here today. Okay? So if it is that you decide that we will, you want to recreate the second algorithm that we did, the second sequence algorithm that we did in C, I would suggest that you go try that. If it is that you could change the values that you have in the for loop to see how the asterisks will come out, or I would even suggest you put the for loop, another for loop inside the for loop and see what will happen. Right? That could be something that I encourage you all to play around with it. So before we go, I'm asking one last time, anybody have any questions, anything outstanding that you want sorted out? Okay, I take silence to mean that we good.
See, I just wanted to say that I really like your code. Your code is very good.
Okay, thank you. I'll take that compliment. All right. So I try to make it readable. I try to put my comments in, and I like to. I know that some people put the bracket on the line below. I put the bracket on the same line with the control statement. It's one or the other. I mean, it's the same thing. Okay? Some programmers willing to fight to the death over it. Huh?
See, I personally will put it on the line below because it better, like when you highlight it, you better see the block it got
The
from under.
brackets.
Yeah.
Okay. Yeah, that's fine. Yeah, that's fine. That's fine with me. It really and truly, I mean, I might say some things to you all in class about it, but online when I'm being recorded, I'll be very nice about people who put brackets on the next line. All right. But honestly, it makes no difference. That was mostly a joke. Mostly. If that's it for us tonight, enjoy the rest of your night. I'll see some of you all in class. I'll see some of you, the rest of you all next week. Enjoy your week.
You too, sir.
Same to you, sir.
Same
How
to
about
you,
you?
sir.
All right.
Bye, sir.
Bye-bye.
Yeah, same to you, sir. Bye.
Bye.